we stopped off with Friday is this one here, x cubed minus 3x squared minus 3x plus 9. Now there's different ways we can solve it, but one way that we can do is by graphing. X to the third minus 3x squared minus 3x plus 3x, or minus 3x plus 9. X plus 9. Helps if I actually type the 9 in. Graph. And we get this here. If we go second graph, this here, it does show us one of the solutions. It's telling us that x is 3, but we do need to find the other two because there are 3 solutions for this here. Since the x to the third, our degree is 3, there will be 3 solutions. And we were able to find one of them by graphing. Now the other method to solve these, that's not by graphing, is factoring by grouping. We did cover this a little bit in Algebra 2. And when we factor by grouping, or solve by grouping, is we group these up into the same amounts. So here, groups of 2 or groups of 3, where all the groups are equivalent in nature. Since we have 4 terms, we're going to do 2 groups of 2 and see if there is a greatest common factor between those 2 terms. So if we look at the first 2, x cubed and negative 3x squared. What is the greatest common factor between these two here? X squared. So we'll factor the x squared out, which leaves us with x minus 3. Now our next one is negative 3x plus 9. What's the greatest common factor between those two there? 3. And if we factor that 3 out of these two, we would have x plus 3. And the goal is to be able to factor it once out of the 2 and then factor it again. Now if we look at the 2 sets of parentheses, are they the same? And that should be negative x. The signs are flipped, yes? So factoring out the 3 is correct. But we're not just going to factor out the 3. We're going to factor out negative 3. Because if I factor the negative 3 out, we do have x. And it's going to turn it from positive 9 to negative 9. And the whole goal of factoring by grouping, one is to simplify it down a little bit, but then once we factor our greatest common factor out of the 2 terms, we should have something in common with both of those 2 terms. Because now looking at these 2 terms, they both have a greatest common factor of what? Not just 3, but x minus 3. This whole term is in common with both, which then we can factor it out. So we group them up, factor something out of both, so that we have something in common with both, and we factor it out. Because if I factor this x minus 3 out of this first term, all I'm left with is x squared. And if I factor the x minus 3 out of the second term, all I'm left with is the minus 3. So factoring this twice took us from x cubed minus 3x squared minus 3x plus 9 to x minus 3 times x squared minus 3. Questions on those here? Well, at this point here, we do have 2 things multiplied together to equal 0, so one of them must be 0. Either x minus 3 is 0, or x squared minus 3 is 0. Well, with our x minus 3, to solve it, we would Add 3 to both sides, telling us x is equal to 3, which we already found. We've determined that already. The graphing calculator told us that. Now the other one, x squared minus 3, there is no middle term. So the first thing we can do is add 3 to both sides, telling us x squared is equal to 3. And then we would square root both sides, because our square root of x squared is going to become x. The square root of 3 doesn't simplify, so we have x is equal to plus or minus the square root of 3. Questions on this here? Now, if we wanted to check these in the calculator, in the graphing calculator, so we can go second trace, second calculate, and the first one is value. And we type in the square root of 3, and it tells us it is indeed 0. That's what we were looking for. We go second trace, value, negative, square root of 3 is also 0. Any questions on this here? We good with this one here? 6x cubed minus 27x squared minus 54x. Well, y equals 6x cubed minus 54x squared plus, what was it, 27x? Was the middle term 27? Yeah. Okay. Got those two flipped. Graph. So we do have two solutions there. Yep. All right. Do we have four terms? No, so we can't factor by grouping, but is there a greatest common factor? X. Yes. What is the other one? 3. Because as much as I'd want it to be 6, 3 is the only one that goes into 6x cubed, which would give us 2x squared minus 9x minus, so we have 3x times our 2x squared minus 9x minus 18. Well, we do have two or more things multiplied together to equal 0. We actually have 3. One of those must be 0. Well, here, x is 0. We could say 3x equals 0 divided by 3, but that's still just 0. And our other one is 2x squared minus 9x minus 18 is equal to 0. So that's our other equation. Yeah. 2x squared minus 9x minus 18. So we have a solution at 6. We don't know what the other one is. Okay, we are there. Trying to figure out 6x cubed minus 27x squared. 7x squared minus 54x. Yep, okay, there we go. So we do have two solutions given to us. One of them, x is 0, because that's the one we factored out. That's why it's not showing up in blue. The blue is giving us the other two, our quadratic. But also, it told us that one of them is 6. So we know once we finish factoring this other one, the other solution that it should give us is x is equal to 6. Yes? All right. Since the third term is negative, our signs are opposite. Now we need to find the factors of the first and third term. Well, factors of 2x squared will have x and x. And then we'd have 1 and 2. We just need to put 2 in one of the two spots, because we can check it and figure out what we need to do next. Factors of 18, 1 and 18, 2 and 9, 3 and 6, yes? Which one of these three do we want to use? 3 and 6, because we know one of the solutions is what? 6, isn't it? So it's probably going to be those there. Now I'm going to put the 3 with the 2 and 6 by itself. One main reason is that, is there a greatest common factor between our 2x squared, 9x, and 18? Well, no, 2, there's not a number that goes into 2, 9, and 18. So if we put the 6 with the 2x, 6 and 2x have a greatest common factor of 2. If it did work that way, that means that the original should have had a greatest common factor also. But it doesn't, so we'll put it this way here. Now if we check this, 2x times negative 6 is negative 12x. 3 times x is positive 3x, which gives us negative 9x like we wanted. So these are the correct factors. And whenever we have two or more things multiplied together to equal 0, one of them must be 0. X minus 6. So x is equal to 6, which we knew already, yes? Well, the reverse of that is just saying that if x is 6, one of the factors has to be x minus 6. Now, if it said one of the solutions was, say, negative 6, what would its factored term be? If this was negative 6, what would that be? If we know one of the solutions, it does give us kind of a hint at one of the factors. Now, the other one, first thing we would need to do is subtract 3, telling us 2x. All I wanted, 2x is equal to negative 3. And then we would divide by 2, telling us x is negative 3 halves. So our solutions for this here are 0, negative 3 halves, and 6. Any questions on this here? Are you ready for the next one? If more than one radical, even them out. If not, get the radical by itself. And then step 2, put both sides to the nth power. So if we look at this one here, square root of 2x plus 7 minus x equals 2. Well, there's not more than one radical, so we don't have to even them out. If not, get the radical by itself. So the first thing we need to do for this here is to get the radical by itself. Well, the only thing with the radical is our minus x. So to get the radical completely by itself, first thing we're going to do is add x to both sides. Questions on this here? Now we need to put both sides to the nth power. And what we're trying to do is to get rid of the radical. Well, we have a square root, yes? So how do we get rid of a square root? We square it. Because if we square a square root, they simplify out, leaving us with (2x plus 7). Now, unfortunately for the right-hand side, we can't just square the x in 2. Because what we're saying is we're multiplying it by itself. And if we're multiplying x plus 2 by itself, we're going to have to distribute. We're going to have to do x times x, which is x squared. X times 2 is plus 2x. 2 times x is plus 2x. And lastly, 2 times 2 is plus 4. So we'd have x squared plus 2x plus 2x plus 4. Now we do have like terms, which would give us x squared plus 4x plus 4. Questions on this here? Well, we have an x squared term, yes, and a middle term. So we need to get this thing equal to what? 0. What do we need to do to get it equal to 0? What else? Subtract 2x. Because on the left-hand side, everything is going to become 0. On the right-hand side, we still have the 2x, or the x squared. 4x minus 2x is plus 2x. 4 minus 7 is negative 3. So I have x squared plus 2x minus 3. The value of a is 1. There's a good chance x squared plus 2x minus 3 is going to graph nicely. Second graph. And when we graph, we're looking for what values of x will make the y value be 0. So negative 3 and 1. And that's it. Questions on this here? Are we good with this here? Trying to read the time. 34. Also, there's a bigger clock in the back. All right, we're ready for the next one. Square root. Oh, yeah. I realized I didn't write the rest of this. 3. All right. T. Yes. Back. Step 1. If no, then solve. Are there any radicals left? So once we took both sides of the second power, once we finish simplifying that, if there's any radicals left, we go back to step 1. If there's more than one, even them out. If not, get it by itself. Put both sides to the nth power. And then we could check step 3 to see if there's any radicals left. If not, solve. If there are, we repeat the process again. And we keep going through that till all the radicals are gone. Now, for this here, we only had to do this once and we could solve. Now, let's look at this one here. Is there more than one radical? Yes. So, from my experience, I find it easier to even the radicals out. So if there is one of them that is negative, or we're subtracting it, I move it to the other side. If they're both positive, flip a coin, which one you want to move. So on the left-hand side, we still have square root of 2x minus 5 is equal to square root of x minus 3 plus 1. Doesn't matter if we put the square root of x minus 3 first or second. We just have to add it to the other side. Questions on this here? We good with everything so far? Now, we talked a little bit about these. In Algebra 2, I think we did one of them, but that was about it. So, that takes care of step 1. Step 2, put both sides to the nth power. Well, what's our power in this case? To the second, because they're both square roots. So we're going to put both sides to the second power. Now, the left-hand side's nice, because we have a square root being squared, and it's the only term. So we're saying we're multiplying it by itself, but these two will cancel, telling us that we have 2x minus 5. Now, as much as we want on the right-hand side for the radical and square to just cancel and that be it, we can't. Now, it will simplify, but we do have to multiply this out. And again, the reason we're multiplying this out is because the radical and the 1 have an addition sign in the middle. We have to multiply it out. If the radical and that 1 had just been multiplied together, it would work a little different. Now, the first thing we're going to do is our square root of x minus 3 times the square root of x minus 3, which really is just the square root of x minus 3 squared, because we're multiplying it by itself. And whenever we multiply something by itself, it's being squared. Then we'll have the square root of x minus 3 times 1, which will give us plus the square root of x minus 3. Then we're going to do 1 times the square root of x minus 3, which is plus square root of x minus 3. And lastly, 1 times 1, which is plus 1. Questions on this so far? Now, one of the nice things here is the square root of x minus 3 squared. Well, the square root and square will cancel, telling us that we have x minus 3 plus. Next part, we have the square root of x minus 3 plus the square root of x minus 3. Are those the same radical? How many of them do I have? 2. So we can just say that this is plus what? 2 square root of plus 1. Combine like terms. Negative 3 and positive 1 are like terms, yes? So what is negative 3 plus 1? All right. So that takes care of kind of step 2 for the most part. Step 3, are there any radicals left? Yes. Go back to step 1. Step 1, if there's more than one radicals, even them out. If not, get it by itself. So we need to get the radical by itself, which means we need to move everything to the other side. So I can subtract x from both sides. I can add 2 to both sides. The 2 in front of the radical we're going to leave alone for now, because right now we're doing addition subtraction. To move the 2 from in front of the radical, we would not add or subtract it, we would what? Divide. Let's keep them separate. So both of these are going to become 0, leaving us with 2 square root of x minus 3. The other side, 2x minus x is x minus 3, because our negative 5 plus 2 is negative 3. Questions on this so far? Now at this point, we can divide by 2 and solve from there, or we can leave the 2 there. Both work. I will show you this here, leaving it alone, and then I can go back and show you with dividing. Well, let's go on and divide it, actually. Not the color I want. Here. We'll divide both sides by 2 to get the radical by itself. So we'll get the radical completely by itself. So that takes us to step 2. Put both sides to the nth power. What's our nth power? It's still the second. Now the first time we did this for this problem, the right-hand side was a little more complicated than the left, yes? Let's look at the right-hand side first. Well, single term that's being squared, so the square root and square would cancel, leaving us with x minus 3. The other side, x minus 3 over 2 squared. Well, it means we're multiplying this by itself. All right. Let's multiply the denominators first. Are you ready? So what are our 2 denominators? And? All right, what's 2 times 2? Okay. That's the denominator. Might as well take the easy, or simplify the easy one first. Now the numerator, we're going to have to distribute through like we did before. We're going to have to do x times x, which is x squared. X times negative 3, which is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is plus 9. So if we combine like terms, we get x squared minus all over 4. Questions on this here? Questions on anything we've done so far? Now, the part that's making this look a little trickier, kind of challenging, or looking kind of challenging, is the fact that that's being divided by 4, yes? What would be really nice? If that was gone, yes? What could I multiply it by to get it to go away? 4, yes? Because if I multiply this side, whole side by 4, and I multiply this whole side by 4, well, here the 4 and 4 would cancel, which would give us x squared minus 6x plus 9 is equal to 4x minus 12. Redistribute. Yes. This is a valid step, because even if you're dealing with everything being decimals, so 0.7x squared plus 0.16x minus 0.25 equals 0, you can multiply everything by 100, because 10 would move it once, 100 would move it twice. Same equation. Solutions would be the same. Everything else of the graph wouldn't, but it would at least give us better, easier time to work with solutions. Now we just need to get this thing equal to 0. Because there are no radicals left, we can move on and solve. So we can minus 4x from both sides, which would give us negative 10x. We can add 12 to both sides, which would give us plus 21. That'd be nice if it graphed, yes? Let's see. Squared minus plus 21. Second graph. 3 and 7. And those are the two values of x that give us the y value of done. Questions on this here? See where we're at. Yeah. Now, I'm not going to go through the whole process of this, but we could have solved this by just squaring both sides. Now, the right-hand side would end up just being 1 squared or 1. Now, the left-hand side, we're going to take square root of 2x minus 5 minus the square root of x minus 3 and multiplying it by itself, which the first one term is just going to be square root of 2x minus 5 squared. Square root of 2x minus 5 times our negative square root of x minus 3, negative square root of 2x minus 5 times our square root of x minus 3. I just moved the negative out front. And then we'd have also the same going the other direction here. Those would cancel. Those would cancel. So we would have 2x minus 5 minus 2, because we do have 2 of them. Now, whenever you multiply two radicals together, you can multiply what's inside. So it'd be the same as saying the square root of 2x minus 5 times x minus 3 plus. This is why I say get those things apart if you can, so we're not having to multiply radicals with each other. But we'll end up getting 2x and x give us 3x. Negative 5 and negative 3 give us negative 8. Now when we multiply this out, we'll get 2x squared minus 6x minus 11x plus 15. Now we'll definitely need to get this equal to 0, or get the radical by itself. Negative 3x plus 9 divide by negative 2 squared again. 2x squared minus 11x plus 15 is equal to, and it just gets bigger and bigger. So it's a lot easier just to make this thing have one radical. Does that make sense? It is possible, just a little bit harder. We'll stop there because in about 7 minutes